this is the answer to Chapter 10, problem number 57 from the Smith Organic Chemistry textbook. And this problem says, draw the products of each reaction, including stereoisomers. Okay, and so that is what I am going to do. So for A here, we are hydrating an alkene, and so the alcohol is going to go to the more substituted carbon, and the hydrogen is going to go to the less substituted carbon. And so what that is going to mean is that our products are going to look like this. Sorry, I was thinking for a moment about the other side of the ring, and I will show you what I mean. So if the alcohol adds to the front, the methyl group will be pushed to the back like that. So there's the alcohol. And then we do need to draw stereochemistry for this carbon, but it doesn't really matter what stereochemistry we give it, because it's going to be cis to the alcohol in one of these and trans to the alcohol in the other. And I will show you what I mean. But we should give it the same stereochemistry in both. Okay, and so those are going to be our products here. All right, and then so for B, we're going to get the Markovnikov addition of this iodine and hydrogen. And so our products are, again, going to be a mixture. So we can have the iodine add from the front like this, or we can have the iodine add from the back, and then it will be dashed like that. Okay, I'm going to move these up a little bit so that I have some room for C. Okay, so then C is going to be the addition of two chlorines across this double bond. And remember, the stereochemistry of this reaction, the chlorines always add anti. So there are going to be two products here, but in both products, the chlorines are only going to be anti. So if this chlorine is on a wedge, then that is going to mean that this chlorine has to be on a dash. And then the opposite will be true as well. So if this chlorine is on a dash, puts this methyl group on a wedge, and then this methyl group on a dash, so that this chlorine can be on the wedge. Okay, so moving to the next page, this is a hydroboration oxidation reaction, and this is always a syn addition of the elements of water. But again, we have no facial control. So this is a syn addition, but we're going to get, again, two products. So that methyl group is going to be unchanged regardless. And then if our elements of water come from the front, they will both be on wedges. And if our elements of water instead come from the back, they'll both be on dashes, which would make this methyl group wedged. And this methyl group will always be wedged. Okay, so then looking at E, we have the addition of HBr across this double bond. And so, again, that's always going to be a Markovnikov product. So the bromine is always going to go to the tertiary carbon rather than the secondary carbon. But we're not going to have any control over which face it adds from. So we can put the bromine wedged, which is going to make this ethyl group dashed, or we can put the bromine dashed, which is going to make this ethyl group wedged. So those are our two choices there. So then F, we have hydrohalogenation. So we're going to add the elements chlorine and an OH here. So this is always an anti-addition. So we can put the chlorine dashed. That'll make the OH wedged, or vice versa. We can have the chlorine wedged, and the OH dashed. And of course, they could add at the other corners as well. It doesn't really matter, right? Because this molecule is a square. Okay, so then for G, this is going to be NBS, DMSO, and water. And so this is going to give us an anti-Markovnikov addition of bromine. And then the water will go to the more substituted carbon. So in this case, that's always going to be the tertiary carbon. So we are always going to get something that looks like this. So always get a bromine here. Let's see. And then we have a methyl group there. Oh, you know what? I'm gonna draw that differently. So we always get the bromine there, and then the alcohol could come from the front face, in which case the methyl group will be towards the back, or the alcohol could come from the back, in which case the methyl group will be wedged. Okay, and so lastly, we have hydration of this alkene. And so since we're comparing a secondary carbon and a secondary carbon, we're actually going to get three products here. And so they're going to look like this. So if the alcohol adds to carbon 2, that will make that carbon a stereocenter. And so we can get addition of the alcohol from the front, which will put hydrogen towards the back. We can get addition of the alcohol from the back, which will put a hydrogen towards the front. Or we can have the alcohol add to the middle carbon here, in which case we're not creating a stereocenter and there's no stereochemistry to account for. Okay, and so that's the answer to chapter 10, problem number 57. Again, the only real way to do this is to know what the reagents do, and then to think about in cases where the reagent can add from either side, think about the fact that you're going to have a mixture of products there. And that's the answer to chapter 10, problem number 57.